Last year, I made a few videos on dynamic testing in software. And I said in that video that I should be doing something on static analysis. Well, here we go. What it does is that it analyzes the code, so the semantics, sometimes builds a model out of that code and is able to make diagnostics. And there are really three categories of static analyzers that I know about. So the first one is code rule checkers. If you have heard about CertC or MISRA, those are standards of good practices if you're doing C language, for example. Code constructions that are inherently more difficult to predict what they are going to do, so maybe that it's much more likely you're going to have a bug in there, or that are going to be extremely difficult to maintain. These are fine. I mean, you should be following coding standards for maintainability, but it doesn't detect bugs. Now, the two other types of tools, they do detect bugs. One of them is going to analyze lots and lots and lots of code and will be able to provide you with some diagnostics, hopefully good ones, that are going to highlight runtime errors. So what kind of errors? Maybe that you're reading outside of an arrays bound, or division by zero, or an overflow. So you're not exactly certain what will happen if this actually happens in the field. The behavior becomes unpredictable, and obviously that's dangerous. The third category actually is able to do an exhaustive analysis of the code in order to detect those runtime errors. And it does so using formal verification. What it does basically is to cascade the range of potential values throughout your program, so it knows at different stages of the execution what are the range of values that can be experienced. So if you have a division somewhere, it can know for sure whether zero could actually be run there, or if it's never going to happen for whatever reason. So it enables you to rule out errors that other tools could not detect. You get assurance that these errors will never happen. It's mathematically impossible. What's the catch? Well, the catch was that analysis time was very long, and also the tools tend to generate a lot of false positives, which people don't like. Now, the good news is that there's at least one tool that actually solved these two problems. And the even better news is that I'm working for them now. So in the future, I will introduce how the technology works.